Hari Om. Our today's lecture is electromagnetic waves in free space, transverse nature of electromagnetic waves. In our previous video, we have derived the equations for the field vectors, electric field, magnetic field, and some scalar function u. Del square E is equal to 1 minus C square delta 2 E upon delta T2 is equal to 0. Del square H is minus 1 upon C square delta 2H upon delta T2 is equal to 0. And for some scalar field, del square U minus 1 upon C square delta U upon delta T2 is equal to 0. So now we have to find the solution for the field equations. So let the trial solution of the equation number 10th, 11th, 12th may be written in the form as ERT, R for space, T for time. ERT is equal to E naught e raised to the power I k dot R minus omega t. E naught is the amplitude of the electric field vector. It is complex. Similarly, HRT is equal to H naught e raised to the power I k dot R minus omega t. URT is equal to U naught I k dot R minus omega t. E naught, H naught, U naught are the amplitudes. K is the wave vector, propagation wave vector, defined as k is equal to k into n cap. N cap is the unit vector in the direction of the propagation of the wave. Value of k is 2 pi by lambda into n. Lambda is c by nu, so 2 pi nu by c into n cap. This is equal to omega upon c into n cap. So n cap is a unit vector in the direction of the propagation of the wave. So now we have to solve the equations given by equation number 3rd A, B, C and D. So equation 3rd A, we have divergence E is equal to 0. So del dot E from equation 3rd A. Del dot E, the value of del is I delta upon delta x, j delta upon delta y, delta upon delta z dot E naught e raised to the power I k dot r minus omega t. So k dot r is the position vector, xi plus yj plus zk. K may also written as kxi plus kyj plus kzk. So I will write here xi plus yj zk and k is kxi kyj kzk and eo is equal to xi eoyj eozk. So here k dot r means kxx, kyy, kzz minus omega t. So when we will substitute the values of all these factors in this equation, divergence E, so we will get I delta upon delta x, j delta upon delta y, k delta upon delta z dot eoxi eoyj eozk e raised to the power I k dot r minus omega t. So when we operate the operator del on the given function, so here we have eoxi kx eoy I ky eozi kz into e raised to the power I k dot r minus omega t. I dot I 1 delta upon delta x e raised to the power I k dot r means kxx plus kyy plus kzz. So we have this equation. This may also be written as kxi kyz kzk dot eoxi eoyz eozk e raised to the power I k dot r minus omega t into I. This is k vector and this is the e vector. So simply we have got I k dot e. So operation of the divergence on the electric field E provides simply I k dot E. Similarly, we can write the value of the divergence H. So divergence H is equal to del dot H is equal to I k dot H. So substituting the values of divergence E and divergence H in equation number 3 A and B, we have I k dot E is equal to 0 and I k dot H is equal to 0. This implies that k dot E is equal to 0, k dot H is equal to 0. If the dot product of two vectors is 0, it means that vectors are perpendicular to each other. K dot E is equal to 0 means electric field is perpendicular to the direction of propagation K, and H is also perpendicular to A. It means that the nature of the electromagnetic waves is transverse. This shows that E and H are perpendicular to the direction of propagation K. So electromagnetic fields are transverse in character. Now we will solve equation number 3 C and D. What is equation 3 C? Curl of the electric field del cross E. This is equal to minus mu naught delta H upon delta T. So here del cross E. Similarly, as we have solved divergence of E and del dot E, we will solve the equation del cross E by making the determinant, and simply we will get the value here k cross E is equal to minus mu naught H is H naught e raised to the power I k dot r minus omega t. So delta H upon delta t will provide us minus I omega into H, or k cross E is equal to mu naught omega H. See, this is your equation number 17. From equation 30, 30 means curl H, that is del cross H is equal to epsilon naught delta E by delta T. So del cross H as usual, I k cross H. So I k cross H is equal to epsilon naught delta E by delta T from equation number 13 minus I omega into E vector, or k cross H is equal to epsilon naught omega E. This is your equation number 18. So from equation number 17, it is clear that H is perpendicular to the plane containing both the propagation vector and electric field vector. Similarly, from 18th, E is perpendicular to the plane containing both the vectors K and H. It means that H is perpendicular to E as well as K. E is also perpendicular to H as well as K. It means that electric field vectors are perpendicular to each other and also perpendicular to the direction of propagation of the wave. So from equation number 17, we can write H is equal to, from equation 17, H is given by K cross E mu naught omega. K is, you know very well, K into n cap. So this is K by mu naught omega n cross E. Omega by K is c velocity of light. So 1 upon mu naught c n cross. This is the value of H. So from here we can write mod E by H is equal to mu naught C. The dimensions of the ratio E and H are equivalent to the dimensions of the impedance. So this is known as wave impedance. So wave impedance denoted by Z0 E by H is equal to E naught by H naught, and this is equal to mu naught C. The value of C is 1 upon under root mu naught epsilon naught. So here we have under root mu naught upon epsilon naught, 4.10 to the power minus 7. Epsilon naught is 8.86 into 10 to the power minus 12. It will comes out as 376.6 ohm. This is the value of wave impedance of free space. Also, this ratio E by H is real and positive. This shows that both the electric field vector and magnetic field vector are in the same phase. They have the same value at all points at all times in the space. There is no phase lag, same phase E by H. So this is all about the propagation of the electromagnetic wave in free space. Transverse nature, both are perpendicular, and phase relationship between E and H. Thank you very much.